Very good morning, students. For this lecturing video session, I am going to solve a problem from the support reactions. Let me just read out the question first. A beam AB of span 10 meter is loaded as shown in figure. Determine the reactions of A and B. Look at the drawing. At A, there is one support there is a hinge support, and at B there is a roller support, and UDL is acting, that is uniformly distributed load is acting, and two point loads are acting on this beam. So in order to draw the FBD, first I need to know the point load that needs to be converted from UDL to point load and the load acting, because this is here, look at here, this is the intensity of the load which is acting from A to this distance up to 4 meter, which is acting constantly. So but to calculate the values, we need to convert that into point load. First that needs to be converted into point load and the load acting point. So UDL to be converted into point load. So the formula for UDL to PL is equal to W into L. W is nothing but the intensity of the load, which is 3, into the L. L is nothing but the span length, which is 4 meter, right? So which is equal to 12 kilonewton. So the units, look at here, this W is in kilonewton per meter and L is in meter. So if you just cancel it, you will get kilonewton. And the load acting point of UDL, load acting point, the formula is L by 2, which is equal to, length is 4 meter, isn't it? So 4 by 2, which is equal to 2 meter. Now I am going to draw the free body diagram. Right. Now listen carefully. So as far as the hinge support or the pin joint support is concerned, there will be two reactions, isn't it? One vertical and the other horizontal. So let me just take this as A. So vertical reaction VA, and the horizontal reaction at A is HA. Right. Let me just extend this beam up to B. So at B there is a rocker, that is, or the roller support, which will have only one vertical reaction, so which can be mentioned as V, vertical reaction at point B, right? And so look at here, this UDL has been converted into point load, which is acting 2 meter from the origin. So at it is acting here. What is the point load? Which is 12 kilonewton, which is 12 kilonewton, isn't it? So up to here it is, let me just take this point as C, and this point as D, and this point as E, right? At D, a point load of 8 kilonewton is acting. At E, point load of 8 kilonewton is acting. And from the origin to this distance is 2 meter, isn't it? And from A to C it is 4 meter, and C to D it is 2 meter, and D to E again it is of 2 meter, and E to B again it is 2 meter. So in totality it is 10 meter, 4, 6, 8, 10. Yeah, that's what it says, 10 meter, isn't it? So now I'm going to apply the equilibrium condition. So applying equilibrium condition. So what are they? Summation H equal to 0, summation V equal to 0, and sum of moment equal to 0. isn't it? So let me just resolve the horizontal forces first. 0 equal to. So before that, let me just draw the quadrant for your better understanding where the positive sign and where the negative sign is. Right. Now look at the free body diagram. Look at here, at A horizontal force is acting, right? In which direction? It's a positive x direction. So HA. Right. Is there any horizontal forces acting on the beam? No. So therefore HA equal to 0. Got it? Right. Next, I'm going to resolve the vertical forces. Summation V equal to 0. So 0 equal to, at point A, the vertical force is acting, which is acting vertically upwards, which will carry positive sign. So VA. And at point here, 12 kilonewton is acting. Right, 12 kilonewton is acting vertically downwards, which will carry negative sign. So minus 12. Let me just move to the next point where 8 kilonewton is acting vertically downwards, which will carry negative sign of minus 8. And at E, again, force of 8 kilonewton is acting vertically downwards, which will carry negative sign, minus 8. And at point B, VB of magnitude, which is acting vertically upwards, which will carry the positive sign. So 0 equal to VA plus VB minus, we just sum this, 28. So this can be written as VA plus VB equal to 28. Let me just take this as equation number 1. So now I'm going to take the moment about the point A, taking the moment about point A. So as the equilibrium condition, summation MA equal to 0. So 0 equal to. So as you all know that even in the origin there won't be any distance. That is, there is no perpendicular distance. That means there is no distance at all. So for HA and VA, this moment will be 0. Let me just consider this point where 12 kilonewton force is acting, which is acting vertically downwards. Therefore, it tends to rotate the object in clockwise direction, so which will carry the positive sign. And the distance from the origin is 2 meters. So 12 into 2 is the moment. Let me just move to the next force at D, which is acting vertically downwards, and it tends to rotate the object in clockwise direction, which will carry positive sign 8 into its perpendicular distance from the origin. From the origin, it is 4 plus 2, which is 6. Let me just move to the next force at E, the magnitude of 8, which is acting vertically downwards, and it tends to rotate the object in the clockwise direction. So positive sign, 8 is the force. And what would be this perpendicular distance from the origin? Its perpendicular distance from the origin is 4 plus 2 plus 2, which is 8. Right. And a force which is acting at B, which should have the tendency to rotate the object in anti-clockwise direction. So minus VB into its perpendicular distance from the origin. Perpendicular distance from the origin is 4 plus 2 plus 2, which is 10. Got it? So 0 equal to 12 into 2, which is 24, plus 8 into 6, which is 48, plus 8 into 8, which is 64, minus 10 VB. So let me just take this 10 VB in the other side. So 10 VB equal to, let me just sum of all the forces, 24 plus 48 plus 64, which is 136. So therefore VB equal to 136 divided by 10, which is 13.6. The unit is kilonewton, right? Because all the forces are in kilonewton, right? So now let me just substitute this VB value on equation number 1 in order to get the value of VA. So going to substitute VB value in equation number 1. So VA plus 13.6 equal to 28. So therefore VA equal to 28 minus 13.6, which is 14.4 kilonewton. Right. So the result, at last we have to mention the result. So VA equal to 14.4 kilonewton and VB equal to 13.6 kilonewton. Got it? So see, mostly the students encounter issue in converting the UDL to the point load. So you should not make a mistake by putting the 3 kilonewton here, because this is the intensity of the load of the UDL. Since we have converted that UDL into point load, this magnitude only you have to substitute in the free body diagram. And the load acting point, you should not mention 4. The load acting point of the point load is 2 meter, which we have converted here. So that you have to specify here. So this is where you encounter the mistake. So don't forget here. So if the load is UDL, then you have to convert that into point load, and the load acting point that needs to be found out. Then you just draw the free body diagram. From free body diagram, you'll have to find the summation H is equal to 0, then apply it, then you'll get the value. Then you will just apply summation V is equal to 0, then sum of moment about A is equal to 0, then you'll find the unknowns here. Hope you have all understood how to solve when you have such support reaction problem, that is with UDL and the other supports like rocker and the hinge support. Thank you.